Hello, everyone, and welcome to JFG tonight. And we are reconnecting with an old friend of the show, Bill Gaede. It's great to have him. How are you doing, Bill?
I'm doing fine, JF. I hope you're doing it just as well.
So you had been attracting a lot of attention on our show back in the days, and I stopped receiving guests for many years. Well, for a year approximately, because I was annoyed with YouTube censorship and the guests weren't up to date in following the YouTube rules. But now I'm on Odyssey, and I've been successful at transferring my audience here, and so it's great we can have discussions again. We can talk with guests. So today is a day of freedom, and as I've announced before earlier in the week, it's the day of the rope. We'll be talking about the rope hypothesis again. Has it been progressing? And for those who have not heard about it, what does it consist of?
Well, the rope hypothesis here it is in a nutshell. Okay,
Mm-hmm.
we're saying that we're proposing that all atoms are interconnected by a rope-like entity, a pair of twined threads. Think of DNA. In fact, I think that DNA copied the model from the rope. Okay,
Mm-hmm.
that's my take on that because they're all twined. And but I think we have to take a step even further down because what I'm proposing is that the scientific method itself that we have today does not conduce to the answers that we seek or that the ordinary person seeks. You see a pencil, and you let go of the pencil and it falls to the floor. And people want to know, why did it go to the floor? What caused it to go to the floor? You see two magnets, okay? Those two little round things, they're magnets. And you let go of one and it sticks to the other. And so the question is, people want to know, what's the mechanism? Well, how does Mother Nature do this? Those are the type of questions people want to have answers to. And the scientific method that we have today does not conduce to any of those answers. Today, we have only irrational explanations, and we've had only irrational explanations for the last 400 years since the so-called scientific revolution, the 17th century. All we've had is irrational explanations for these things. In the case of gravity, they say it's warp space. So we have this canvas, that's the way they illustrate it, but they say it's a four-dimensional concept, time and space, that's warped, and that's gravity. And I'm not sure with that you can explain why this pencil falls to the floor. Is gravity is space-time warped in this vicinity? And then magnets, they cannot tell you why one magnet attracts another from a distance, and on and on and on. So the issue is, these are the questions people want answered. The common man, they don't care about equations. They don't care about, experiments that people did out there. They want to have answers to these simple questions. And here we are 400 years later after the so-called scientific revolution, and we don't have answers. And I'm saying that the reason we don't have answers to those questions is that the scientific method itself is flawed, or better yet, the scientific method that we're using today is really a mathematical method. It has to do with mathematics. And the mathematicians, what they've done is they've taken this method and turned it into the scientific method. What is it about? It's about descriptions. You observe something. Well, if you observe something, does that mean you understand it? They talk about the scientific method being the study of blah, 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 blah. If you study all week, it doesn't mean that you understood. You can get a 0 on the test. Okay, so studying itself does not give you understanding. Predictions. They say we can predict. Yeah, with an equation, you can predict many things. I can say that, if the lion runs, I don't know, at 40 kilometers per hour, if he runs in one straight line in 1 hour, he will be in such and such place. That does not give us explanations, the fact that we can predict things. And so, what I'm saying is that the scientific method that we have today does not conduce to the questions that people ask. I go into Quora. Quora is a site that answers questions, scientific questions, and all other kinds of questions.
They're very good in physics. Very interesting to see different perspectives on the questions answered.
Yeah. And so the issue is people go in there and they ask these types of questions. How does a magnet attract another? What does an atom look like? Why doesn't the electron fly away? And on and on and on. And so nobody gives them an answer. Everybody says, here's the equation. Here's the description. And it doesn't go beyond that. And I'm saying the first thing we have to do is attack the scientific method. I'm saying the scientific method has to do not with what we have today, which is a mathematical method. It has to do with explaining to another human being so that that person can understand the mechanism that you propose for a given phenomenon. So if I'm going to talk about gravity, I got to give you a mechanism, not so that you believe it, but that you understand it. And if I'm going to talk about magnetism or electricity, I got to show you what I mean by electricity. I got to show you the mechanism. And it's not for you to believe it. It's for you to understand it. And that's what we do with a rope model. I'm saying, here we have a rope. Okay, let's see if I can do it this way. Here, farther away. And my hands, I don't know. Can't get it. I'll do it.
Yeah, we see it. We totally see it.
Okay, here it is. Okay, so we have two atoms, which are my hands, right? And we have a rope-like mechanism that interconnects them. The two threads of the rope are exactly what make up also the atoms that are at either end. So not only are the atoms made of the threads, but those threads later on come out of the atom and twine around, go to another atom, which is made of the same threads. Then on the other side, we have the same two threads coming out, twined out to another atom, to another atom, and to another atom. The whole universe is simply atoms interconnected by two twined threads. That's essentially the model. Very simple model.
And the two twined threads, what are they? The blue and the red?
In this case, blue and red, just to distinguish them, but it's a single thread in the entire universe. I'm saying this is the entire universe. Okay, just a closed loop thread. That's it. Mm-hmm. And this turns into every single piece of matter that we have out there. And so this is a little different than what mathematical physics proposes. Mathematical physics says there are discrete particles. They're all individual. In other words, one is separated from the other. They're not connected in any way. And of course, with that model, you cannot explain the force of pull. I cannot pull on you if everything is just discrete particles. One particle cannot pull on another particle. And so I think that's where it fails.
That is the intuitive feeling, but we could be in a universe where pulling is possible by sending particles. I mean, it's just, you just have to accept the universe is such that you can pull with gravitons.
How do you pull with particles? I want to see the mechanism.
Well, and this is what I wanted to go back to. So from the beginning of your speech there, the distinction between mechanistic and descriptive explanations. Intuitively, it exists. I mean, I've been doing science and I was very interested in mechanism and very not interested in descriptions. However, is it a fundamental distinction? Because in the end, if you're like trying to explain the mechanism behind the car working, you're going to have the engine, you're going to have a description of the transmission, and you're going to have all of these parts and how they work. But ultimately, what you'll have is a description of these parts. And so is there a ultimate distinction between mechanistic and descriptive physics? And if so, what is it?
Well, again, I'm saying that we need to have mechanisms if we're going to talk about the universe. Are we saying that the universe does not function according to some kind of mechanism, like a car functions according to a mechanism?
Well, what I'm saying is that ultimately any mechanistic explanation will boil down to a description of the mechanism, right? And so even if you invoke something behind what you observe, let's say I invoke the transmission behind the working of the car, ultimately the description of the transmission will be a descriptive theory. It will be a bunch of mathematics that say when you have something rotating at this speed with this kind of gear, it results in that much of a movement of the wheels of the car. I will have a satisfactorily mechanistic explanation of the car's working, but that mechanistic explanation will be a description of the universe.
I'm saying there's a difference between a description and an explanation. Those two words are not synonyms. Explanation is not description. If I find a box on top of a shelf and I say, how did the box get up there? Okay, I want to try to explain how the box got up there. So I say, well, I had a rope and it goes around a pulley and I tied the box to the rope, pulled on the rope from the other side. The rope went around the pulley, and that's how I got that big box, which I couldn't lift myself. That's how I got it on the shelf. That's an explanation of a mechanism. That's different than saying the box got up there. That's a description.
Yeah, but
a description
in my view,
is not an explanation. And what I'm saying,
So in my view, mechanisms are meta descriptions, because what you described is, okay, a man took the box and went there. That's a description of a man, and presumably the entire description of all of the atoms making up the man who brought the box there would be sufficient to explain why the box is there.
If I say that this magnet attracts that one, and I just state that, that's a description. I haven't explained how that
even
happened.
If you were to say there are little leprechauns in the microscopic structure of the universe that are pushing the magnet here and pushing the magnet there, even then you'd be only describing leprechauns.
No, because you're focusing on the wrong aspect. What you're saying in that case is, what is the mechanism? How did the two magnets come together? And now you're going to go through an explanation of that mechanism. That's different than saying, oh, there were two leprechauns. That's a description. So far, I haven't explained anything. The explanation has to do with the mechanism itself. That's not a description. Again, description and explanation are not synonyms.
I think that for a given observable phenomena, its description might be different from its explanation. But what I'm saying is that ultimately the explanation is made up of little other descriptions.
Yeah, but the explanation is the whole story, not the individual steps.
Okay, the whole story.
In other words, the explanation is the sum of how did this happen? What was we talk about causes and we talk about, what caused the phenomenon to happen. What was the mechanism? And that's different than saying, I'm just going to describe a chair. It's blue. You can say that as part of your explanation, but you cannot say that because you say that the chair is blue, you've explained anything.
All right.
We have to distinguish between description and explanation.
There are already people asking questions in Super Chats. As a reminder, you can send Super Chats and questions through Entropy. The link to Entropy is right below the video in the description. And our survey of the night is, what do you think about the rope hypothesis? Very good, interesting, or against it? We will know if the rope passes tonight. Fractal Man has sent 2 super chats. His first is Bitcoin to the moon, boys. Bill Gaede, you are so woke on the rope question. Are you woke on the cryptocurrency question and Bitcoin?
Well, I buy crypto also.
Oh, yeah.
So I play the game.
Okay. Wonderful, because it's been going extremely well for crypto in the last few months. There was a drop recently, and today there is a recovery. So you've been predicting that the financial system would eventually crumble. I guess Bitcoin is the way out naturally.
Yeah, I think it's a modern way of betting. Not you don't have to go to Vegas anymore. You can do it from home. And with this COVID, lockdown, I think it's perfect for a lot of people. They just stay at home and pull that, one-armed bandit.
That's another thing that people are asking about. Is Bill Gaede into the vax stuff? We have learned that the Canadian protest against mandates and vaccination mandates has been enlarging itself. There are now movements in Toronto, the city of Toronto getting blocked by tractors today. There are other cities where a protest is headed, including Quebec. So are you on the side of protesters there? Are you for mandates? And what do you think about the vaccine?
Well, for me, it's a subject that is completely irrelevant, first of all. But there's a difference between a guy like me that this year I'm going to be 70 and a guy who's 20 years old. There's a big difference. In my case, I don't care if they give me a shot because I'm going to die one way or another, with the vaccine or without it. I don't have too long to go. I don't think I'm going to make it to 100. Mm-hmm. But for a guy who's 20 years old, who has to go to work, who has to be among other people, but that guy, they're scaring him on one side saying, if you don't get the vaccine, you're going to die. And on the other, the guy said, well, I don't believe maybe this is some government hoax or something, And so, but the guy has, supposedly 50, 60 more years to live. So he's got a different decision to make than I do. That's the first thing. The other thing is, I would have never gotten the vax at all because I don't need it. But I got the vax because I had to travel first to Iceland and then to South America. And so, and if you traveled, the kind of headaches that you have if you don't get the vax. They're just going to make life so miserable for you. You might as well get it. And again, the difference is between a guy who's 70 or 80 with respect to a guy who's 20 or 30.
Yeah, if I was 70, I might get it because I would be like, maybe it's going to save me a couple of years. But you see through this that you've been extorted, essentially. Do you experience it as extortion? That for traveling, you've been asked to do something to your body?
Correct. Absolutely. It is an extortion any way you look at it, because when they compel you to get a vaccine, or you will be locked down, you will be quarantined, you'll be having all kinds of problems. My sister-in-law, she couldn't get into a bank in South America because they said, you need a vaccine or you need some kind of or PCR test or whatever. And she couldn't get in there to get her money out. So, when you get into situations like that, it's compelling. Yeah,
absolutely. Fractalman has sent another super chat. He says, does the string fray over time from constant breaking? And what is it composed of? So do the strings break in your theory?
They're not string. We call them threads, first of all, but yeah, okay. Second, they don't break. And third, they're not made of anything, because if you go into quantum mechanics or mathematical physics in general, right, they talk about elementary or fundamental particles. What is an elementary or fundamental particles? Well, right now it's defined as a particle that's not made of anything smaller. Okay, and supposedly the electron is one of those particles. Now let's go to the rope model. We're saying that everything out there is essentially a single thread that turns into atoms, ropes, so on down the line. Okay, so everything in the universe is interconnected, because if we could untangle all of it, all we would get is a single thread in the entire universe. This thread is not made of anything because, again, it's an elementary entity, meaning it, by definition, it's not made of anything. And if it were made of something, that means that there is space between whatever, let's say it's made out of two parts, whatever we'll call them A and B. So this thread is made of A and B. If that's the case, that means there's space between A and B, because that's the only way you would be able to distinguish A from B. And we're saying, no, it's a single thread made of a single piece. Okay, it doesn't stretch, therefore, because if it could stretch, it would create new matter. And it's an elementary or fundamental entity, meaning it's the ultimate. That's where the buck stops. It's not made of anything smaller that makes it up, because otherwise people say, well, what is that other particle made of? What is A made out of? Well, it's made out of X. And what is X made out of? And it keeps going and going and going, which is what you have in quantum mechanics.
Now, a couple of things are emerging in my mind, and it's amazing because we've been talking about this like 5 or 6 shows for hours, and I'm
Yeah,
still, there are questions that are totally new that we've never explored, and they're just
that's
popping in
fine.
my mind. That's a testament to the idea of Bill Gaede, whether you agree with it or not. It's certainly a
Okay.
mind stimulator. So I'm starting to be worried, Bill Gaede. I'm starting to be worried about your nuclei,
Okay.
neutrons and protons. Won't
Okay.
they blow up with all these ropes around them if you don't have a strong nuclear force? Do you have the equivalent of a strong nuclear force in your model?
Well, we don't have a strong nuclear force because strong nuclear force is artificial, just like quarks are artificial. I mean, the strong nuclear force, which are the gluons in quantum mechanics, okay, and their job is to keep the quarks together. In other words, they prevent the quarks from flying out of the proton or neutron, whichever, right? And so the issue here is the following. The quarks, in fact, I was explaining this the other day, that the quarks artificially have been given 1/3 charge. Why? Because if you have two up quarks with 1/3 charge, with 2/3 charge each, you have 4/3 minus 1/3 negative for the down quark. Then you have 4/3 minus 1/3, you have 3/3, in other words, one charge. And that's why the proton has one charge. Why does the neutron have 0 charge? Because it's the other way around. You have two down quarks, which are 1/3 each, negative, and you add 2/3 of one up quark, you get 0. But
Mhm.
that's mathematics. So we've never seen a quark. All that is just mathematics to justify why the neutron doesn't have charge and the proton does. And the same thing goes with the gluons. They paint them as these little corkscrews that go from one quark to another. And when you look at that, when you analyze that, they say, well, it's really a little particle that's spiraling going from one place to another. Okay, if that's the case, how does one quark attract another? So again, this gluon strong force is just made up, just like the quark is made up. Just all these particles are just made up because no one's ever seen one of these. No one's ever photographed. We can't see that far in there and that small. And all it is just an accounting procedure to make sure that we get the proton being 1 charge and the neutron being 0 charge. And I'm saying, well, what do you do with the electron? I mean, how come the electron has 1 charge, negative charge? How do you do that with these parts, with 3 parts? Is the electron also made of, 2 up quarks and 1 down quark? I
Well,
mean,
the
how
electron
do
is
you get the negative?
fundamental
How do
in
you
the
get the
model.
negative charge on the electron?
The electron is fundamental in the model, but so are you denying the existence or the evidence for the existence of neutrons?
No, absolutely not. In my case, we just have a different model of the neutron. We're
Okay.
saying that just like the proton is the convergence of threads, a neutron is a convergence of ropes. And I have a picture of that. I could show it, but I don't have one here to
Yeah,
show
it's
you right
okay.
now.
Yeah, I'm trying to imagine this. So a neutron would be kind of what happens to the atom, where the threads are detaching themselves and forming single ropes that are detached. But the neutron failed to do that in some way. Failed to do that. Sorry.
What do you mean it failed
Because
to
you say
do
it's a
that?
convergence of ropes. Do they
Yeah.
arrive at the center of the atom?
Yeah, in other words, imagine gazillions of ropes crisscrossing, especially in our region where we have lots of matter. Okay,
Mm-hmm.
and I'm saying that all these ropes coming from every atom in the universe, they have to be crisscrossing somewhere in the universe. That convergence of ropes, wherever those happen, that's what I'm going to call a neutron. And what that neutron can do, it has a free, and I'm going to talk about a free neutron now, one that's not inside an atom. If you see one of these neutron, which is a cross point, where all these ropes converge and continue going, where they all cross, we're going to call that a neutron. That neutron has the ability for one of the threads to come out and form part of the electron shell, in which case, if the thread came out, all it left within the enclosure within the membrane, all it left is single threads, and that's a proton star covered by a electron shell, electron membrane.
And does there need to be any special event for a crisscrossing of ropes to lead to an observable neutron? Because it's my impression that there would be no, under this theory, there would be no particular reason to believe that they would concentrate at the middle of atoms.
I think you would have lots of atoms in the universe. In other words, just like you have many atoms, you have gazillions of neutrons, and those are inside the atoms. A lot of them are inside the atoms. They move together with the atom wherever the atom goes because they're trapped within the electron shells. Remember that
it's the electron shell containing all this?
The more shells it's got.
So it's the electron shell containing all these neutrons in a finite space?
Yeah, in other words, if you have, for example, in the center of one atom, and we'll talk about something higher than hydrogen, because hydrogen doesn't have a neutron. But you take any other element, and what you're going to have is a neutron together with a proton inside the nucleon, and that's going to be covered by an electron shell. And you can keep going with that and have more shells depending on, whether you have an S1, S2, or a S3 level. So you have all these spheres that are encapsulating spheres inside, which have neutrons inside. One inside another. It's a nested system.
We have another super chat. Fractalman says, how does your model explain phase changes? Have you looked into the transition between liquid, gas, solid?
That's a question of temperature. In other words, temperature is a question of frequency, and frequency is under the rope model. It's just a number of links that you have for a given, length of rope. And so you could have, for example, higher frequency, meaning that the links are shorter. And in that case, you have heat, and you have when you have the links are longer, then you have cold, which is essentially the model we have today for the spectrum. And the same thing applies to my model. In other words, if you have two atoms and the rope that's connecting them has many links, in other words, high frequency, you have heat. And when the links are longer, then you have cold.
Now, it seems to me that if you're, let's say you're intercepting a ray of light, so you have some space filled with gas or liquid, the ray of light comes in. If I heat this thing, does it influence the frequency of the light that's coming from outside of the place that I'm heating?
Well, it gets the influence from the signal from the ropes that are connected to whatever you're looking at. Let's say you're looking at water, for example. Okay, so you have water and you say, well, how does the water heat? Well, the way it heats is that you have the ropes that are connected from the thing that's heating that water. They're all connected to every molecule inside that pot of water. So every molecule that's inside the pot is connected to whatever's heating it, whatever you're going to apply heat to. So it's got, along each one of those ropes, it's going to increase the frequency, meaning that the links are going to become shorter and you're going to have more links. And that's the high frequency that's going to stimulate that atom to vibrate faster until, it heats, boils.
But that's a description of the source of light, right? Which would be at a certain temperature. My question is, can I heat a ray of light that passes through me and change the output for the observer that's beyond me? In other words, can heat influence light as it's already been sent?
That's already been sent.
Yeah.
What the atom can do, what one atom can do, if it's excited, it's going to vibrate and pump at a faster speed, the quantum jump. And by doing so, it's going to torque the rope at a faster rate. And it's not that light is going to go faster. It's just that it's going to change frequency in exchange for in other words, the link length is going to become shorter. Okay. And that stimulus is going to go to another atom and so on down the line. So at some point, the rope is light. The whatever goes along the rope is what we call light, and that signal is going to increase, meaning light is going to travel at the same speed, but what's going to change is frequency in exchange for wavelength. In the case of our model, it's going to be the length is what's going to shorten, and you're going to have more links. And now
I'm wondering about one aspect, which is the uni-thread of the whole universe. So the whole universe would be a single thread. Yeah. One of the properties of a single thread, as opposed to, say, I could take your theory and make it a multi-thread theory. What if there was just an infinite number, or close to an infinite number of threads, essentially linking all atoms, but not being linked one to another in terms of beginning end? What is the advantage of having a unithread? And do you realize that the feature of a unithread is that there is a ultimate order in the sense that if I start from a place of your unique thread, I will go through some atoms. So there will be some atoms that I will encounter before, and then some atoms that I will encounter after. There will be an order effect in describing the universe.
Well, the problem I have with many threads, essentially, is that, and I have this in another context, but I think I can kill two birds with one stone here. If an atom, for some reason, is not connected to me, I can't see it, because the only way I can see it is through the rope that is connected from that atom to me. In other words, if there's a galaxy out there and it's not connected for some reason to me through these threads, because it's another system, another thread system out there, I would not be able to see it. And that's why I'm saying there could be parallel universes under my model, in this sense that if there's another universe next door to us, and that whole thread that makes up all that matter, none of that is connected to our thread, our universe, we would not see any of that universe. Okay. And so I'm saying that within the universe, what we see hopefully is everything that is connected to us, because the only way we can see is through the rope, the torsion on a rope that is connected to that atom that we're seeing. And the only way I can picture that, maybe there's someone smarter than me can come up with a better model within the rope model. The only way I can understand that is a single thread.
Okay, but it's counterintuitive to me, because what you're saying essentially is that what we see, we must be connected with a rope, with the matter that we see, to see it. Yes. But suppose that I'm in a certain spot and there's kind of an obstacle hiding a star from me. If I move a little bit right, I start seeing the star. I move left, I don't see the star anymore. Are there ropes disconnecting here, or how do you interpret blockades of light?
I'm saying the rope goes right through the atoms that are in between your eyesight and the star. In other words, you have a star, you have something in between, and you have you. Okay, so you're saying you move to the left, now you can see it because it's directly. And you say, okay, now I move, and there's this other star or whatever in front of me. Maybe there's the moon or whatever. It's in front of me. I can't see that star anymore. And you're saying, what happens to the rope? The ropes are still connected to your eye from that star, and they go right through the moon or whatever's in front of you.
But you don't see it anymore. So there's some interception. There's some interception of the torque, or what?
Well, what you have is right now, let's assume it's the moon, okay? Now the atom of the moon, first of all, it's closer. Second, it's interrupting your field of view, and you're seeing that atom. The other one, the other row, goes in the same direction, but all you can do is see that atom that comes directly to your eyes. First, because it's closer by. Second, it's got higher intensity. Okay. And then it's got to do also with the molecular structure of what you have in front of you. You take a piece of paper let's put a piece of cardboard, and you can't see through it. And you take a piece of glass and you can see through it. And you say, well, why can I see through the glass? Why can't I see through the cardboard? And that's got to do now with molecular structure, not exactly with the ropes. In other words, now you got to analyze the molecular structure.
But this molecular structure of the cardboard ultimately is such that in your theory, it would absorb rope stimulus that corresponds to light, right? It
Right.
would absorb it.
It will absorb, in other words, because of its molecular structure, cardboard has the ability to block light. But block light means it receives the signal, but it doesn't vibrate and relay the signal to your eye.
And then I was looking at a beautiful picture. I probably can't find it anymore, but it was from NASA, I believe. And it was the curvature of massive, I don't know if it was a star or maybe an entire galaxy. Somehow a structure out there in space was curving light. So much so that you were looking at this thing and you had flashes of light coming at you on top, at the bottom, on the side. Essentially, light was curving and getting to my eyes. You don't believe in that, if I remember correctly. But looking at the picture, I was like, there's a pretty convincing case here that some star behind that star is sending rays of light through the four sides, some on top, some at the bottom. And there's no other way to explain this to me than light has been curved. Do you believe that light or that your ropes are getting curved?
Okay, there's a little bit of explaining to do there. The first problem is that under the mathematics, as I call it, mathematical physics has no explanation for that phenomena. They talk about curved light or bending light. That's not what's happening, even according to mathematical physics. If light is a little photon, a little particle, then they should talk about deflecting, not about bending. There's a difference between deflecting a ball when you play baseball or whatever and bending a banana. Okay, bending and deflecting are not the same thing. So what these people are saying, that the little ball curved around what? Around space-time, they say, because the star or whatever got in between there, pushed space-time downwards, created this depression, and now the little photon ball is going to roll around or slide around that curvature. Mm-hmm. That's already an irrational explanation because they're using a concept called space-time. They're saying that time is warped, and that's how they get that explanation through. So that's the first thing we have to clarify. Under the rope model, it's a piece of cake. Very easy, very simple. Every atom in the universe is connected to every atom in the universe. We're all connected, okay? So now we have the star behind the sun. We have a little star behind the sun, and the sun is essentially eclipsing that star, okay? But that star, every atom in that star is connected to every atom in the sun, meaning it's also connected to every atom in the corona of the sun, okay? The corona is the outer part that glow, that gaseous envelope that the sun has. Every atom in the corona is tied to your eye. So what happens? You have an atom from the star behind the sun tied to an atom in the corona in a straight line because, it's tight. It's like this, right? Mm-hmm. So it's a straight line. And from that atom to your eye. Now multiply that times gazillions of atoms. And what you have is you've made that curvature, so-called curvature. You did it all with straight lines.
It's a little bit. I think I've seen you. Ropes. I think I've seen you invoke this also in the case of gravity and how we are attracted to a planet, and essentially the border of the planet are pulling on the side of the object that's falling down. Is that a good parallel?
It's not pulling. I want to make sure that people understand. We use the word pull for gravity, and I'm saying it's not pull. We have to understand the mechanism under the rope model, okay? And what I'm saying, there is no pull. It's not like gravity is pulling on an atom. For example, an astronaut. He's full of atoms, right? It's not they're pulling on each atom. What happens is as the astronaut drifts towards the Earth, the ropes that connect each one of the atoms of his body to every atom on Earth, they open up. See, when he's far away, they're all in a single coaxial, you could say, almost in a straight line. But as he approaches the Earth, the ropes fan out. They change their angle with respect to the astronaut. So the angle is changing. And so because there are more independent ropes acting outside the axis, That's the acceleration of gravity, which gives us the notion that, oh, he's being pulled to the earth. No, he's not being pulled. He drifts towards the earth. As he falls, the ropes fan out, and he falls at a faster rate as more ropes participate.
More ropes
all done with
participate
straight
when
lines,
you're
no
closer.
pull.
When you're closer to the
sorry?
planet, more ropes. Why? Because it seems that you're linked to the.
Not more ropes. Not more. More
Okay.
independent ropes.
Okay. More and
They're
how,
not on the same
why
axis.
are they independent?
I'm sorry.
Why
They're
do they
independent
become
because
independent?
of the angle. Imagine if you have 100 ropes and I have 100 ropes. We hold them. You hold 100 and I hold 100. If you're at infinity, it's a straight line. But as you come towards me, the ropes fan out. They widen out. That's what's happening.
It's a matter of kind of almost a resolution concept where if you look closer to the thing, the fact that the rope is not at the center because the center is occupied by some other rope makes the dimensionality start to matter as you get closer.
Yeah, what I'm saying, as an object approaches another, every atom in that object, if they're far apart, as if it were a single coaxial. But as they come together, they widen out, and now each rope acts independently. Mm-hmm. But there's no pull. It's just that gravitational attraction is simply a drift that produces independent ropes that are outside the axis.
So going back to the curvature of the light, I imagine three bodies in perfect alignment. The corona of the sun. Now, I can imagine a rope linking the corona of the sun to this star extremely far from us. And then I can imagine a straight line from that corona to my eye. But that to me is a triangle. That is not a curved experience of light that would make me see the star beside the corona. At best, I would see the star into the corona.
What you have to do is multiply that times 1,000,000 because you're looking at only one rope and you're saying, oh, one rope from one atom to an atom in the corona to an atom in your eye. That's only 2 ropes and 3 atoms. But if you look at the corona is it's not even a flat disk. It's a curvature. The corona is curved around the sun, and you can see certain width of that corona. So all those millions, gazillions of atoms there, each one at a different distance, one in beside the other or between others. When you put all those atoms together or those ropes together, yes, you should see the whole sun, that whole star in the distance. You should see it, around the corner.
So you're telling me
there's a puzzle that people have that they can make these curved lines all with straight lines. You make all these straight lines, but you superimpose them and you create this curve. And you say, how did they produce the curve? We did it all with straight lines. That's exactly what I'm proposing.
I believe that Richard Feynman had something like this, maybe, but it was about the path integrals in quantum physics, but I'm not sure it's directly related. Now, so I want to understand are you saying that there are atoms escaping the sun beyond the corona, and that I would ultimately only see curvature of light within a space where atoms have been leaving and are physically present? Or are you saying that the ropes are so packed in at the corona of the sun that essentially they have to space out, and some of them will get from totally outside in empty space, and eventually that's where I could see? In other words, what I'm asking is the phenomenon of the curvature of light as is interpreted by current physics. Would it be observable in perfect vacuum, or does it have to be some matter escaping from the corona, allowing this kind of visual illusion?
Are you saying under the rope model or
under your rope physics model?
Because once again, I clarify: mathematical physics doesn't have an explanation. Arthur Eddington supposedly said, "I've answered the question," but he hasn't, because we don't know if that little photon is rolling around. First of all, it's not bent; it's deflected, and then the second thing is being deflected by curved time. And
Yeah.
that's nonsense. That is poppycock. So that I want to put that one aside. But then under the rope model, it's not a question of atoms leaving the corona. I'm saying that all those atoms are buzzing around in the corona.
Inside the corona.
Yeah, and they're all there. It's not like one is leaving or anything. They're stuck to the sun because of gravity, because each one of those atoms is connected to the main body of the sun. Mm-hmm. But you have this tenuous gas, you could say, this region we call the corona, and there are millions and millions of atoms there, one behind another, one next to the other, one between two, and so on. There are millions and millions of atoms in there. And so, if each one of those is connected to the star behind the sun that, the sun is eclipsing, we should be able to see that star around the corners only because of the corona. The corona is sending that signal to our eye, relaying. I call it relaying. It's relaying the signal that is receiving from that star through the corona to your eye.
Yeah, but it was my impression that we saw a big distance between the curved light that we observe and the gravitational objects. It seems to me that it's very far from the corona that we can observe these curvature. Maybe I'm wrong. If I remember the image, there was kind of a space between the astral entity that's curving the light and the astral entity that was observed.
Well, you have to remember there are atoms out there that that we can't really see. In other words, the corona itself has a gradient, and there's the outer gradient. You probably won't be able to see those atoms.
All right. Now, thinking about I'm thinking about the sun now because we've talked about it for so long. Free electrons, I believe that in the state of fusion, essentially the atoms are scrambled and the electrons are not revolving around the nucleus, if I'm correct. Which form does it take in the rope model, the fusion state?
The fusion of what?
Well, fusion, like if you're in the sun, how do you model the sun? Because you were talking of atoms in the corona, but my understanding is that there are no atoms in the sun, or they form only temporarily and they get eventually boiled through fusion into a state where there's a complete detachment between electron and proton.
Well, my model is very similar to the official model in that sense. We have a little bit of the difference, and I can explain that difference to you. Well, in other words, I agree totally that the sun works through fusion. In other words, you take 4 hydrogen atoms, you squash them together, and you form a helium atom and release so-called energy. That's the official model. The energy that releases, that's according to my rope model, is that it releases higher frequency along the ropes. And that's what reaches us, higher frequency. That's the so-called energy that's being released. It's thread that's being released. But where we differ is the following. This is where we differ with mathematical physics. Mathematical physics says that because of the pressures inside the center of the sun, the particles are traveling at great speeds. That's the official version. Mm-hmm. I'm saying under the rope model, that doesn't happen. Under the rope model, it's pressure. It's not speed. It's not that, see, they're used to accelerating particles in the accelerators, and they think that that's what's happening inside the sun. In fact, they illustrate them like that, where they show that the particles are moving at great speeds, the hydrogen atoms are moving at great speeds, they're colliding, and from 4 of those that collide, they form a helium atom. I'm saying that's not what's happening. What's happening is because of gravity, because of that constant pressure on the center, all these atoms are just crowded in a bus and being squeezed by all the other passengers. So they're fused together through pressure, not through speed. That's where we differ. Other than that, my model, I agree with the official model on that. I just have a different interpretation of what's happening inside the sun.
Is there a Pauli exclusion principle for ropes? Can ropes be at the same place at the same time?
Well, let's first clarify that. According to the quantum mechanics, says a particle can be at 2 places at once. Now you figure that one out. You need 2 beers for that one, okay? At least. But let's go the other way around. Can two particles be at one place at the same time? According to quantum, they can, and according to the rope model, they can. So we don't have a problem there. We see eye to eye on that. Where's the problem? The problem is how they fuse. In other words, according to the official model, the one they use, and then they deny, it's the planetary model of the atom. You have a proton in the center. We'll just talk about the hydrogen because it's the simplest. You have a ball in the center, and you have a little ball that goes around somewhere in a region known as an orbital or a energy level. Okay, so this little bead is somewhere in there. And what they cannot explain is why that bead doesn't fall to the proton, which is positive, oppositely charged, right? And why it doesn't fly away. I mean, why doesn't it do either of those two things? And so this little bead somehow magically stays faithful to the proton. Under the rope model, it's a membrane that is encapsulating what I call the proton star. It looks like a star, okay, or like the quills of a porcupine that's rolled on itself. Okay, so all the spokes are pointed outwards, and that's encapsulated by the electron membrane. What happens when for example, two hydrogen atoms come together? They blend, they merge, and they form that typical figure 8 molecule, which is the H2 molecule. Okay, so we have an explanation for that. We're saying it's physical. And what we're having is one membrane fuse or melt into the other one. They sort of screw into each other, and they form this figure 8. Under the current model, the quantum model, they have no explanation. They just say it is so. What's merging? The two energy levels, the two orbitals, what's merging? If orbitals are regions and energy levels are regions. Region is a concept. You can't say love merged with intelligence. What does that mean? And here they have orbitals and energy levels, they merge together. They form that figure 8. What merged? So they don't have an answer, but we do it with actual membranes. We're saying the electron is a membrane.
And is that the kind of the blue part of the rope, if I remember correctly, or red?
Those are just for the purposes of illustration.
Yeah, but I mean, is there one of the color of the rope? Is it the one that forms the electron shell?
Again, just to keep in line with convention, we say that one of the threads goes around and forms the electron shell. We arbitrarily call it the magnetic thread because we take that from the magnetic field. And that's, again, just arbitrary, just a name, nothing more than that. And the other one goes through the center, and we call that the electric thread, again, because of electric field.
Because I'm wondering then, if it's one of the thread that becomes the electron shell, and you're talking about the merging of electron shells, do they kind of get a record of this that would survive, say, the explosion of the proton star? Did the order of the universal thread change at the moment where there is this kind of merging between two threads that are electron shells and that become only one?
Well, we need to understand how they merge. What happens is, imagine the rope, okay? And my fists, again, 2 atoms. That's the best I can do there.
Yeah.
And what happens as one atom approaches another one, the rope disintegrates. In other words, undoes itself until one of the threads just continues going into the other, the thread that makes the electron shell of the other atom. So what they do, they sort of screw into each other.
They screw, but they don't. I was wondering if it was like, if I was to take a soldering machine and I was to solder 2 parts of your blue rope, would that illustrate the process in proton stars?
No, bad analogy.
Okay.
Bad analogy. No, I'm saying it's more like if you just take a rope, do it at home, just to visualize what I'm trying to explain, not for you to believe it, but just undo it. Okay, so you have the rope there, and now you're going to undo the rope this way. Okay, we're going to undo the rope, and you can see the threads are now parallel in that case, right? Well, imagine 2 atoms now touching at that point. One is drawn into the other membrane of the other electron membrane of the other atom, and vice versa. And this one's drawn in this direction. So they sort of screw at the point where the ropes meet. And then the next rope next to it does the same, and the next one. And so they're all sort of screwing into each other, the membranes.
Okay.
So it's not welding, it's like undoing of the rope as one atom approaches another.
All right. BJB says, if time permits, please explore Bill's time as a communist spy. Thank you for your super chat, BJB. This is something we've covered on the show back then. I don't think there is much to add for now, but we'll get into the political stuff and the current geopolitical situation as soon as we can get resolved with all the questions. A lot of people have been sending questions. Human Drill says, regarding gravity, wouldn't want big rope pulling in one direction be stronger than many different small ropes pulling in different directions? I would think the angle decrease would weaken the pull. Unless the total pull of the many small ropes would be greater than the pull of the big rope. Why would the small ropes be stronger than their big rope counterpart?
First of all, there's no pull. We should get rid of the word pull. I use it too, by the way, so I'm guilty, because we always talk about gravitational pull, or that gravity is some kind of pull. So we use the word pull. I want to make sure that that's not the case. Okay, so whenever I use pull, it's don't think of pull. Okay, it's just drifting towards something and the ropes fan out. Now, if the ropes fan out, they're always under tension. In other words, every rope is always under tension. There is no pull along any of the ropes. The rope is always made of, again, it's just tight. It's pulled tight.
There is no rope that goes loose.
Exactly. So
except
they're
when
as tight
forming
as
an atom.
possibly can be. And all you have within that is the speed of light, which is different torsions along each one of those ropes, because one might have an influence of one entity and another one of another. So one has higher frequency and the other one has lower frequency, but all the ropes, light always travels at a constant speed. Velocity of light is little c is 300,000 kilometers per second. That's a measure of the tension on the rope. All ropes have the same tension. So it's not like one rope pulls more than another. It's a bigger rope and the other guy is a smaller rope. All ropes have tension between any two atoms. That's all there is. And all we have is just as one object approaches another, the ropes fan out. And the more ropes that fan out, you have acceleration of gravity.
I just realized, as you were speaking, I just realized under your theory, Hawking radiation doesn't exist.
Hawking radiation is funny because they had to, let me tell you what the story there is real quickly. It turns out that they had nothing to see. They said to the astronomers, go look for it. Well, what do we look for? I mean, a black hole is black, and the night sky is black, so we won't see anything. They said, and so they had to look for something. And so Hawking radiation came around. They said, oh, by the way, space itself is made out of particles. One is positive, the other one is negative. The black hole sucks one in, and the other one is left to be free to come to your eye. So they say, now you have something to look for, because there should be some radiation coming out of black holes.
But it's coming out way
so
too slow. It's way too slow and way too weak to be observable. So we won't resolve that one with experimentation. Men Like Gods says, Mr. Gaede, I brought your name up to Alexander Unziker, and he said he was familiar with you, but not your rope theory. Perhaps he was confused. Regardless, I would love to hear an in-depth discussion with you and Mr. Unziker or PM Robitaille. Are you familiar with their work? Thoughts?
Well, with Unziker, we've met here in Germany. We've met. He came to to Frankfurt, and we met. We had a morning breakfast once, and we had a lot of talk about, especially when they came out with a picture of the black hole. And he thought it was a lot of baloney, and so we had a long discussion on that, a 2-hour breakfast. And then we also met before that in Austria, in Salzburg. We had a get-together there. What was it? I think 2014. We had 2 of them, in fact. And I think Unziker was in both of them. He was at least in one of them. And yeah, I know his theories quite well. He's a relentless critic of mathematical physics, of some of the claims that people make out there. Robitel, I'm not familiar with, but I know who he is. But I mean, I haven't heard anything about him.
The photo of the black hole has been quite a moment that I was highly anticipating until I saw this donut. There's something that remains mysterious to me, which is, okay, that could be a black hole that absorbs light, but there is such a large ring of light around the black hole. Why is there no ring of light here obstructing the blackness of the black hole? Like, if there is so much matter converging toward this black hole that there is basically larger than the black hole itself, there is illuminating fusion matter all around it. Why is it not all around it in a 3D way? Why can we see the dark spot? That's a question that remains in my mind still. What is your understanding of this picture? Do you think it's just an artifact, a joke, or do you believe in it?
The picture, I think, is real, okay? But we got to know, we have to understand what we're staring at, okay? And what we're staring at is, according to these people, okay, they should have explained it a lot better. We're not looking at a black hole. What we're staring at, according to them, is matter falling into a black hole. What we're seeing is your sink drain, your drain. You put water in there, right? And water falls into the drain. It spirals around. You can see the water, but you cannot see the drain, so to speak. That's essentially the case with this picture. They're saying what we're staring at is water falling into the drain, okay? And what the picture is about the water falling into the drain. It's not about the black hole per se, according to them, because again, the black hole is a singularity. Well, what are you staring at? Well, what picture are you going to take of a singularity? Especially if it's a mathematical singularity, there's not much to take a picture of. So what they're saying is what you're staring at is not really a black hole, but water falling or matter falling into the black hole. But what I'm saying is, you can't have that because under mathematical physics, a black hole is zero dimensional. It has no size. You might say, Bill, you're crazy. No. Let me tell you, it has no size, not according to me. Chandrasekhar, he got the Nobel Prize. You can look this up. Don't take my word for it. He got the Nobel Prize for proving that a black hole is zero dimensional. Has no size, no length, width, or height. And you had Arthur Eddington, who said, Chandrasekhar, you're crazy. He said these in the 1920s when he was Chandrasekhar's supervisor, and he said, we're not going to allow you to publish this because what you're saying is a star can collapse to zero size. And Einstein said the same thing. He says, you're crazy. You're saying that all the matter gets crushed out of existence. And that's exactly what Chandrasekhar got his Nobel Prize for. Don't take my word for it. Look it up. Chandrasekhar proved a black hole is zero dimensional. If it's zero dimensional, what the hell is a black hole?
Well, the thing is, could you acknowledge that even if the black hole itself it would be zero dimensional, it represents a phenomenon of gravity into the universe such that a much larger space actually is encompassed by the event horizon.
I'm saying that the so-called black hole phenomena has nothing whatsoever to do with gravity. It's the insistence of mathematicians who have not found any other mechanism that they always talk about mass and gravity. I'm saying the black hole has nothing to do with mass. The black hole has nothing to do with gravity. This is a magnetic phenomenon. It's got to do with the magnetic field of the galaxy that swishes down all the threads. Remember, under the rope model, it's a bunch of threads. That's what magnetic field is. And you have these physical threads, gazillions of them, just sweeping down on a star and forcing it to roll around in a circle. And so they say, oh, there's a star moving around in a circle. There must be something very heavy in the center. We'll call that a black hole. And I'm saying there is nothing in the center of that orbit. What it is if you put a charged particle in a magnetic field, it will go around, and it will go around nothing. And that's what a black hole is.
Are you a secret agent of the Electric Universe guys?
No, I wouldn't work for them.
No? No, because they seem extremely motivated with their stuff, with seeing magnetism and electricity as a bigger force than we typically do.
Yeah, but
so
what
in
they
that
do is
they
they
are in
say-
line with you.
Yeah, but no, but they're not, because first of all, they use the quantum model of the atom. That's where they fail. And the quantum model is the planetary model. That means a little bead going around. And what they say electricity is this electron bead moving from atom to atom. And that's where we have a problem, because under the rope model, electricity is not a little bead that moves from atom to atom. It's a whole bunch of merged electron shells in a row, and they all twirl in situ, in place. So their electricity is very different than my electricity.
All right. William Runner says, JF, say hello to Bill for me. Filthy Bayozo says, is the black hole possibly what we humans call God? I don't think Bill Gaede is very warm at the idea of God. Right?
Well, we got a problem with God, good old God. I mean, he's a nice fellow, but he doesn't exist. Poor fellow, he's not around. In order for God to be something, he's got to have shape, first of all. Then we can say, okay, God is something, because I can paint him, I can make a picture of him, I can take a snapshot or whatever. But that's not enough. If he wants to exist, if God wants to exist, he's got to have location. There's got to be distance between my chest and his chest.
God
Otherwise,
is everywhere,
God doesn't
Bill.
exist.
Jesus is everywhere.
Yeah, so are quantum particles.
I wanted to talk a little bit about the political situation before we conclude. So have you been following this whole Russia-Ukraine? It's amazing to see the American media propagandize. They've been actually ridiculed by even some American media are starting to question the rationality of the Biden administration. They started claiming that Putin was preparing some coup, was preparing some kind of fake video where he would make it look like Ukraine attacked him to charm people on the internet. And there's no evidence for it. It seems that America wants war with Russia. What's your take on what has been happening around Ukraine?
I don't think it's the United States that wants war against Russia. I think they want to create the ambient that there is going to be war. And this is a chess game. It's a chess game. And again, the Americans have the whites, like Bobby Fischer usually was a good attacker with his whites. And you had Tigran Petrosian, which was the Russian counterpart. He was the good with the defenses, especially with blacks. And so this is a good analogy for what's happening now. The Americans cannot fight Ukraine, this war in Ukraine, and say they're going to win. They don't care about that. As far as I'm concerned, they're not interested in that. This war is against Germany. This war is against Germany first and France second. Okay, those are the targets. They want to stop this pipeline, which is supposed the Nord Stream, that is supposedly going to be approved by June. And they want to stop that. They've been trying that for several months to try to stop Nord Stream. The Germans said no. And now they're going to use this excuse of Ukraine to say, oh, look, the Russians attacked Ukraine, and so now stop the Nord Stream, and we're going to pull Germany and France more to our side. Because right now, Germany and France are more or less independent of the United States. They have treaties not only with Russia, but with China, and the United States wants to stop that. I think the United States wants these two countries to be more under their umbrella. And so this war, I think, is against Germany. Now, what happens? If Russia doesn't attack Ukraine, well, no problem. The United States wins no matter what. The United States moves its pawns, its rook, its knight, its bishop, right, on the chessboard. And the other guy has to defend himself. If he doesn't defend himself, no problem. I'm going to continue attacking until at some point he's going to have to do something. And again, I don't think there's going to be the United States is going to go into Ukraine and fight for Ukraine. First, because there's no treaty. Ukraine doesn't belong to NATO, and NATO has no reason to support Ukraine other than, a pat in the back. This is an issue where they say, I hope you attack Ukraine so that we can justify to the Germans and the French why they have to be on our side for not only being against Russia, but also against China. So this is a war against Germany. This is the Third World War, I could call it, and it's always Germany that loses.
Oh, wow. That is very interesting. Very insightful. But if you're right, and I'm Putin, then the only error I could make is to truly attack Ukraine. And so the best decision for Putin is to not create escalation, to have as many soldiers as possible to defend the current border, but not go further, not try to acquire anything in Ukraine, and make sure that Nord Stream 2 goes into function while not doing any provocation so as not to give the moral high ground to America.
Yeah, but again, Bobby Fischer would attack and the other guy had to defend himself. And he can't just say, okay, you do whatever you want. I'm just going to sit here. No, he can't sit here. Putin, the Russians in general, they have to do something because the United States says, oh, you're not doing anything. No problem. We're just going to move some missiles into Ukraine and put some troops there, and it's all for fun. And so the Russians at some point will have to act, and that's what the United States wants to do, force the Russian hand. Mm-hmm. Now, there's another take on this that you might want to consider, and that's what I discussed the other day. I'm saying the following. Wouldn't it be nice? I mean, Russia, or better yet, the Soviet Union, lost a lot of the countries it was over in the Warsaw Pact. All these countries are now essentially on this side, on the, you can call it the blue side, the American side. And the only thing that remains on the other side is Belarus and Ukraine, more or less. Now, the Ukrainians, they speak Russian, and the eastern provinces essentially have already fallen into the hands of the Russians. Ukraine is not a big prize for the Americans. Again, the prize here is going to be Germany, and the United States wants to provoke this war. But let's assume that the United States wins in the end, and not because it wins a war, but because there's an internal coup that overthrows Putin and his mafia, his group of people, okay? If that happens, and you get a friendly government in Russia that's friendly with the West, now that would be nice for the whole world. Suddenly we have these two countries which have been enemies for so long, at least for most of the 20th century, right? And now these countries, let's assume, were friends. And now there is no enmity between the United States and Russia. That would be positive if we could obtain that. And if we had to choose, we would say, well, it's better for there to be a coup in Russia, have a friendlier government get up there, and we're all friends finally. Now, I don't know, that would be nice. It's a dream, but it would be nice.
Yeah, that would attract a lot of hate to America, the way Iran, for example, has been the victim of a coup and has been after just more hostile to America. But then if America is making a war against Germany, why are they scared of Germany? They're scared of the production capacity of Germany?
First of all, Germany is a competitor of the United States, like Japan is a competitor, like France is a competitor. It'd be nice if these so-called competitors were neutralized and, they could better organize their whole production, not only for manufacturing, but also services, etc. If they could organize that or they would all be in accord without competing against each other, but they would work in unison, it'd be a lot better for the United States, for the economy of the United States. Right now, Germany is a competitor. You gotta stop that. Germany, whether we don't look at it that way, is an enemy of the United States from a manufacturing, economic point of view. It's an enemy.
And then in terms of disruptions to the supply chain, one of the big problems is Taiwan. If Taiwan is taken over during all this time, if we're too attentive to this northern situation and China takes Taiwan, we lose a source of chips, electronics. Is that therefore in the interest of the America to continue defending Taiwan?
Well, that's a tricky situation. First, because the United States is already on record saying that Taiwan is part of China. That's already in the books. So it's very hard to, let's put it in reverse. Let's say California decides to secede from the Union and say, well, we don't want to be part of the United States. And China comes in the defense of California and sends some weapons there and so on. Well, the Americans wouldn't like that at all. And that's a situation that's
I would love
in Taiwan.
it. I would root for China and the independent Republic of California.
No, but this is the situation with China. Taiwan, according to official version, United Nations, even sports, Taiwan is part of China. Mm-hmm. And so it's a province of China, and it's a tricky situation. But the United States has an agreement with the Chinese, mainland Chinese, saying that, yeah, okay, Taiwan is part of China, but you can't take it by force. And, right. And that's the excuse they're going to use to make sure they give weapons to Taiwan and all the necessary assistance for Taiwan to defend itself. Now, you're saying the Taiwan Semiconductor, which I worked with, by the way. I worked with Taiwan Semiconductor. Yeah, I did. And Taiwan Semiconductor is one of the companies that supplies most of the chips in the world. I think it's the number one company right now. You don't want that falling into the hands of Chinese for two reasons. One, because they have suddenly, control of the faucet. They can say, well, we're not going to sell you any more chips. Those chips are coming to China. And then the other one is that suddenly, you gain a lot of knowledge as far as chip manufacturing, because again, China's like 6-7 years behind the West. And so they would gain a lot with that. But then there's the counterpart of that, and that is that before the Taiwanese lose their country to the Chinese, they could destroy TSMC, Taiwan Semiconductor.
Mm-hmm.
Or ship it out or throw everything into
the burnt land policy, burnt land in the sense of destroying everything and letting go of the territory?
Russia did it many times, did it with Napoleon, did it with Hitler. They just burn, slash and burn.
Wow.
Don't leave anything behind to the enemy.
You think like a spy. Now, before we conclude, someone had asked the question about your life as a spy. Perhaps you can give us an idea of maybe a story that you've been... So you were a spy for which agencies and who were you working for?
I don't know anymore.
Yeah, I remember some turncoating, if I remember correctly your story.
No, first I approached the Cubans, okay, and I worked with the Cubans for many years. 12 years, and through them, with the Soviet Union, with the Warsaw Pact. And the way it worked is the Cubans never told the Russians, the Soviets, right? Never told them who I was. But we had the head of the KGB. His name was Kryuchkov at the time. And Kryuchkov met a delegation from the Cubans that went to Moscow and delivered tons of material that I had delivered to the Cubans over many years. And so they gave them all this stuff, and suddenly they say, this is a big coup that you have against the Americans, that you've got this guy in there, but they didn't know who it was. Okay, they never knew. The Russians never learned about me. Mm-hmm. And it turns out that, over time, I lost my faith in communism. Big mistake in my life. Yeah. What can I say, And because of that, I turned myself into the CIA, okay, and they started using me in an operation against Cuba. Okay, wow. So now they started using me against Cuba. Turns out that we worked for 2 years with FBI, but CIA worked with the FBI. They were together in this thing because they all were there in Texas, in Austin, Texas. I had the FBI, the CIA. We were like 5 people there, 2 from the CIA and 3 from the FBI, and we worked on providing certain type of information that would help them penetrate the interior ministry of Cuba. And what happened was that, I was there working with them for 2 years. Meanwhile, I worked at Intel Corporation. I got a job at Intel using them as a reference. Intel found out about me, what I had done at AMD. They confronted me with it, said I had to cooperate with an internal investigation, which was really to get information so that AMD could put me behind bars for what I did to AMD. And so eventually they fired me. But before they fired me, I was able to take the Pentium, which was the number one, the state-of-the-art chip, and took it to South America and began peddling it to Iran and to China.
Wow. Countless Russians may have experienced the pleasure of NES emulators, playing little games on Pentium 5 years in advance, thanks to Bill Gaede's dedication to information sharing. Isn't that beautiful? And you get imprisoned for this. This is scandalous.
Yeah, 3 years. I was 3 years in prison.
3 years. Oh, not so bad.
Yeah.
But I don't like the way the system, turns against you and it decides that, oh, you have these freedoms and, oh, sharing is great. And then you do it and they put you in jail. That's what they do with the trucker convoy too.
Let me just say one thing. I went 3 years to prison, partly because I had, it was like this. Here was the prosecutor and here was me. And I had my hand in the nuts of the FBI and they had their hand in my nuts. And it's who squeezed first, because they were going to put my wife in prison. That was the issue. And so that's how they had me. And I had a lot of information on the FBI and the CIA. The CIA was raising national security issues. They were not going to allow a lot of that information to get into the court. And that would have gone against the FBI. I had agents filmed with, and them paying me and so on. So they were in big trouble with me, but they had my wife. They were going to put my wife in prison. So even though there was no law, I had to plead guilty because it was too risky. And I've seen that happen to people inside the prison, how they go after their wives.
Absolutely. Bill, thank you so much for coming. I have some announcement to make solo, so I'll continue the show. It was a pleasure talking to you again, and we'll do it again very soon.
Okay, bye-bye.
Bye-bye. All right, that was a pleasurable experience once again. Always fun to speak with Bill Gaede. What an amazing man.